Without further ado, Simon, take it away.
Hello, everyone. Today I'll be talking about WebSockets, but before I begin, I'd like to start by thanking SingleSprout and Codesmith for sponsoring this tech talk. So like I said, we'll be talking about WebSockets, and just at a high level, WebSockets are a communications protocol that enables bidirectional, full duplex communication between a client and server over a persistent single socket connection. So let's think about when we might use sockets. We would use them when we want our applications to have either one or both of these features of real-time updates, which kind of speaks for itself. You get updates on changes to data in real time as they happen. And bidirectional communication. This means both the client and server can send and receive messages simultaneously. Developers can leverage these capabilities that WebSockets provide to create collaborative real-time web applications. So if you're thinking of apps that you might use regularly, think a market price tracker in which you see the price update real time, online multiplayer games, or chat applications like WhatsApp or Slack. So now, to understand why we use WebSockets, it helps to understand what we were using before. So on your screen now, this is a diagram of the conventional model for web applications. It had a client and a server and was characterized by this request and response exchange. So the client sends an HTTP request to the server, and the server then takes the request, processes it, and sends back a response with the relevant data. When the web was first created, this looked really simple. The response that the server would send back was an HTML document, which the client would load and show as their user interface. The web was completely static, meaning the client had to continually reload each page as they made a request. And this changed a little bit with JavaScript when it was introduced in 1995. JavaScript was able to embed some scripting capabilities into web pages, but it still made for a relatively static experience. So around 2005, Ajax emerged on the scene as developers wanted to create something closer to a real-time application. Ajax stands for asynchronous JavaScript and XML. And what it does is it introduces an intermediary between the client and server. You can see it's still a familiar request response model, but this Ajax engine does two things. It pulls the server on the client's behalf, so it sends those requests, and it renders the user interface. It does both of these things silently in the background, and it'll update parts of the page as it gets updated information retrieved from the server responses. So this meant the user no longer had to refresh the entire page and created a much more seamless browsing experience. Now, let's say we wanted to create a Twitter feed where we can see what someone posts or tweets when they tweet it. How would we get an updated feed with the standard request response HTTP protocol that we were looking at? Well, one approach would be polling. Polling is when you send requests to the server for updated data on a set interval. It can be 2 seconds, 10 seconds, a minute, whatever you set it to be. So in this case, the client would have to send a request to the server every time they wanted updated data. And one of the drawbacks is because it's request driven, the client would have no way of knowing when there's updated data, besides when they get a response back with updated data. You can see there's tons of potential for delay in receiving up-to-date information. It also comes with some pretty large overhead. So repeated requests to the server waste a ton of resources because with each request, the server has to establish a new connection. it has to parse the headers of the request and then perform a query for that data. And oftentimes the header actually outweighs the relevant data being sent back. So after the server gets the new data, it generates and delivers a response back to the client. And like I was saying before, there's no guarantee that this response will have new data to offer. So this can create a lot of unnecessary overhead in terms of network traffic and server load. So this is when Comet came into play. Around 2006, Comet emerged, and it refers to a web application design model that allows the server to push data to the browser whenever updates are available. So instead of periodically polling the server, the client uses long-lived HTTP connections. So there are two ways of achieving this design model. And the first way that I'll go over is long polling. So this is a similar technique to short polling, the technique I just outlined. But instead of polling constantly, the server elects to hold open a connection made by a request and will deliver a response once new data becomes available or until a timeout threshold has been reached. So the long polling is characterized by an initial GET request, the connection remains open, and when an update happens, the server sends a response back. And usually at this point, the client will issue another request immediately to ensure that it'll get the next update when it's available. This moves us a little closer to a real-time experience and also helps alleviate some of the issues with short polling by creating fewer requests, but it still puts a high load on the server. Another approach or another way to achieve the Comet model is through HTTP streaming through or via the SSE protocol, which stands for server sent events. So the way this works is a client sends an initial GET request to initiate that connection. And this HTTP connection remains open indefinitely until the client explicitly sends a message to terminate the connection. Then the server, once that connection is opened, uses the event source protocol to stream updates to the client whenever they're available. This enables efficient, low latency server to client streaming of text-based data. But one major consideration here is that this communication is unidirectional. The client can't send any data to the server after this initial handshake. This is still useful. So think about applications like subscribing to a feed, whether it's news or Twitter, or electing for live sports scores during a game. So like I said, long or HTTP streaming, although useful, still has that major drawback of being unidirectional in its communication. So enter WebSockets. So what are WebSockets? Let's finally get into it. Rather than a single or unidirectional communication, WebSockets, like I said in the beginning, enable bidirectional full duplex communication between client and server. And this is done over a single persistent socket connection. And full duplex here just is a telecommunications term that means both people on the phone can both talk and hear each other talk at the same time. So here's a visualization of what a WebSockets protocol looks like when the client and server are communicating. It starts with something familiar, an HTTP request and response handshake. But beyond this, the WebSockets are fundamentally different from HTTP. They improve performance by eliminating the need for a new connection with every request, so they're much less resource intensive. This helps save bandwidth, improve latency, and makes applications more scalable. This also flips the paradigm on its head of HTTP being request-driven and WebSockets switches over to an event-driven protocol, which is arguably a prerequisite for real-time applications so that users can react to changes as they happen. So WebSockets are the only transport that allow bidirectional communication over the same TCP port, and the client and server can exchange messages at will. So let's compare the HTTP protocol to the WebSockets protocol. WebSockets are full duplex and event-driven, whereas HTTP is half duplex and request-driven. Although they both have the initial overhead of the HTTP GET request, afterwards, there's minimal overhead per message with WebSockets. And WebSockets are also stateful, meaning the connection, the server will keep the connection alive until it's terminated by either party. One thing to know, HTTP is still useful. It can be a good choice when apps rely heavily on CRUD functionality, and there is no need for the user to respond quickly to changes. So the WebSockets technology has two core parts, the first being the WebSocket protocol. And this is made up of the opening handshake and the data transfer. So just two very simple and basic examples of what the opening handshake looks like. A GET request indicating that the client wants to upgrade the connection from HTTP to WebSockets. And these are the 5 required headers that I've underlined here that I won't go into at this moment. The server must return an HTTP switching protocols response for the connection to be established. It also has some required headers that I'm also not going to get into. The data transfer is the communication over the WebSocket. So the WebSocket protocol communicates with frames, which are data fragments that can be sent from either side. And on the screen, you're seeing a visual representation of what those frames look like. They contain header and application data, and they're written in binary syntax. We won't get too into the weeds of what each bit in the frame represents, but there are different kinds of frames that I'll outline. There are text frames, which contain text data, binary frames, which contain binary data, ping and pong frames, which are used to check the WebSocket connection, and close frames, which do what they sound like, they close the connection. There are also other service frames, but I also won't go into those in this talk. So how can we as developers use WebSockets? The WebSocket API is how we implement the WebSocket protocol. Almost all modern browsers support the WebSocket API, and it's intuitive, simple, and trivial to use.
Okay.
There are also plenty of frameworks and libraries out there, both open source and commercial, that implement this API. So this API, just a quick overview, it supports 4 types of events. An open event, which is raised when a WebSocket connection is established. A message event, which is fired when data is received through a WebSocket connection. An error event, which is fired in response to unexpected failures or issues. And one thing to note is errors cause the WebSocket connection to close. So an error event is always followed by a close event. There are also 2 methods that the API supports. A send method, which is how you can communicate and send messages, and a close method, which closes the connection. So now I'm going to get into a demo of a very simple app that I built using WebSockets, that's built using WebSockets. So this is just a simple cursor location sharing application. You see I have one instance of the client where you see this blue cursor, but as you add clients, each client gets an individual colored cursor. And the power of this is you can see in real time these cursors moving from the different clients. So you can imagine this would be very powerful in a collaborative editing tool like Excalidraw, where you want to enhance people's communication in real time. I hope that demo showed you some of the capabilities and potential for WebSockets in your own applications. If you'd like to look more into WebSockets, I've provided some links to resources here. And I hope we can connect and talk more about WebSockets. Thank you.
An excellent presentation, Simon. Let's all unmute for a moment to give him a round of applause.